Hello, class. Well, today we're going to be talking about how to determine the rate of change or slope and initial condition or B when you have a word problem. Okay, we're talking about a context. So, in a real world situation, you will not usually have the slope or the y-intercept handed to you. Okay, you're probably going to have data in a table. Okay, so you're going to have something that looks like this, and you're going to need to determine the slope and the y-intercept. You're going to have to do some work. Okay, so when we're doing this, remember, the slope is how much something's changing, and the y-intercept is where it began. So how much it changed, or how much it's changing each period, and then where it originally began. So let's take a look at a few examples. Okay, in our first example, Susan deposits the same amount of money into a bank account every month. The table shows the amount of money in the account after different amounts of time. So we've got at 6 months, $534, 8 months, $684, 10 months, $834, 12 months, $984. Okay, so you can see here that the months, okay, every time you go up in the table, you're going up, well, 2 months. Okay, and if you look at the amount in each one, okay, that's going up 50. She's putting in $50, it looks like, every 2 months. Well, if I want to know how much would be in the account at 0 months, I got to go backwards in time. So at 4 months, she would have, well, 534 minus 50, so she would have 484. Okay, if I go back in time another 2 months, I'm going to be at 2 months. She would have 434. And if I went back another 2 months at time 0, okay, that's important, time 0, she would have $384. Okay, so the initial amount B, okay, that's in the y-intercept, Susan deposited in the account would be $384. Okay, is the account increasing or decreasing? It is increasing. Okay, and it's increasing by $50 every 2 months. Okay, if I simplify that, that simplifies down to $25 per month. Okay, now you see that special word per. That's one of our slope words. Okay, that's telling us how much money is going into the account each month. So that 25 is actually our slope, and that's real important. When we get to this next question, write an equation to model the relationship. So we're going to use our slope-intercept form. Y equals the slope, 25, times the number of months, x, plus how much you had at the beginning, $384. So after any number of months, x, I can figure out how much money is in that account by using that equation right there. Okay, let's take a look at another one. Josh is printing extra flyers to distribute. The flyers are printed at a constant rate. The table below shows the number of flyers he has after different amounts of time. So again, we take a look at this. Here, the flyers are going up each time, each chunk of time here, by 25. Okay? They're going up 25 each period of time. And these periods of time are going up in increments of 5 minutes. Okay, 5 minutes each time. So I want to go backwards in time to figure out how much he had, how many flyers he had when he started printing. Well, that means I'm going to go from 10 to 5. Okay, and if I'm at 98, if I go back 10, he's going to be at 73. Sorry, if I go back the 25, he's going to be at 73 flyers. And if I go back another 5 to 0, that's going to be 48. So how many flyers did Josh have when he started printing? Well, he had 48 flyers when he started printing. Okay. Is the number of flyers increasing or decreasing? Again, it is increasing. Okay. It is increasing each and every time. By how much each minute? So he is doing 25 flyers in 5 minutes. That means he's doing 5 flyers per minute. 5 flyers per minute is what he's printing. Okay, write an equation to model that situation. Well, again, we're going to have y equals our slope, and our slope is right here with our per 5x plus the number he started with here plus 48. There you go. Couple more examples. Okay, Charmaine is adding water to a swimming pool at a constant rate. The table below shows the amount of water in the pool after different amounts of time. So, like we were doing before, we're going to go ahead and take a look at this table here. Well, the time is going up by 8 to 12, 12 to 16, 16 to 20. That's going up by 4 each time. Okay? And the number of gallons, the amount of water in the pool each time, is going up from 153 to 197, 197 to 241, 241 to 285. Well, that's going to be 44 each time, going up by 44 gallons each time. Okay, so how much water was in the pool when it started? Well, that means we need to go backwards. Well, going from 8 and 153, I'm going to have 4. And if I subtract 44 from 153, I'm going to be at 109 gallons. And after 4, if I go down another 4, from 109, I'll go down 44 gallons to go from 4 to 0. I go from 109 to 65 gallons of water were in that pool. Okay, so how much water is in the pool when Charmaine started? 65 gallons. Now this time we're going to complete the sentence. The water in the pool is, in this case, it is increasing. So I'm going to cross out decreasing. Okay. By how many gallons per minute? Well, in this case, it's going up 44 gallons every 4 minutes. So that's going to simplify to 11 gallons per minute. Okay. That's 11 gallons per minute. Write an equation to model the situation. Well, in this case, again, y equals our slope, in this case, 11x, plus the starting point here of 65. Okay, that tells you about Charmaine and her pool. One more where you're talking about Tony getting on an escalator. Okay, Tony stepped onto an escalator moving at a constant rate. Actually, I think it'd be funny if you had an escalator that wasn't moving at a constant rate, though you see a lot of people fall. But that's neither here nor there. The table below shows his distance from the first floor after different amounts of time. So here we go. Times 6, 9, 12, 15. Distance 980, 890, 800, 710. So in this case, the time is going up by 3. 3 and 3. But the distance, this case, isn't going up, it's going down, okay? It's going down 90. It's going down 90 and down 90. Okay, so how far was Tony from the first floor when the elevator started moving? I think that's supposed to be escalator. I'm going to change that. Anyway, so that means I need to get to 0. Well, if I was at 6 and 980, I'm going down as time goes forward. So I'm actually going to go up as time goes backwards. So from 6, I go to 3, and 3 is going to be 1,070 centimeters. Okay, and from 3, I go to 0, and that's going to give me 1,160 centimeters. So he was 1,160 centimeters away when the when the escalator first started moving. Complete the sentence. The escalator is moving. In this case, it's not moving up, it's moving down. So I'm going to cross out up at the rate of, well, we have 90 centimeters over 3 seconds. That's going to simplify out to 30 centimeters per second. Okay, so 30 centimeters per second. Write an equation or model a situation. The good old slope-intercept form. Y equals, now in this case, because we're going down, we need to make sure we put our slope as negative 30 x plus his initial condition where he started, 1,160. Okay, there you go. I hope that helps. If you have any questions, feel free to see me in class. Thank you.